Hello dear students, welcome to Genique Education. So this is the fourth episode and I am going to discuss another important question regarding the equivalent circuit. So first of all, read the question carefully. The question is a 10 kVA 2000 by 200 volt 50 Hz single phase transformer when working on a rated voltage at no load takes an input of 125 watt at 0.15 power factor. Okay, so first of all, let's understand the first line, the first statement. This is the specification of the transformer, its kVA rating, its voltage rating, its frequency rating. Okay, and next statement, when working on rated voltage at no load takes an input of 125 watt at 0.15 power factor. Its meaning, no load test is performed. No load test performed on the transformer, that too in the HV side. In the HV side, or anyway simple, whether the test is performed on the LV side or in the HV side, will get the same amount of losses, that is the iron losses. In the no load test or the open circuit test, the power consumed by the transformer is only the iron loss, not the copper loss, because in that case the no load current is negligible, and we also neglect the resistance, correct or not? So in this case, the no load power, so this is the iron loss. No load power means this is the iron loss of the transformer, that too at open circuit test. Now its percentage leakage impedance, okay, that is percentage Z based on the kVA rating. The absolute quantities and the per unit quantities. What is the relation between the absolute quantities and the per unit quantities? What is the advantage of this? You already know, but in this question the per unit impedance has been given to you on the base, the kVA rating. For any per unit quantities, it must have some base. That base is both the voltage base and the kVA base. The kVA base is how much? Tell me. The kVA base is the rating, the own ratings, the own kVA ratings, meaning 10 kVA. So kVA base is how much? Tell me. 10 kVA. And the percentage impedance is how much? 0.5 plus J1. Okay, because this is an impedance, meaning percentage resistance per plus percentage leakage reactance, resistance reactance. Okay, if the transformer delivers 10 kilowatt at 200 volt at 0.8 power factor, lagging on LV side, meaning you are exciting the transformer at the high voltage side, that is 2000 volt, and you have connected a load on the low voltage side, and the load is consuming 10 kilowatt of power at the power factor of 0.85. okay, so power consumed is given, power factor is given, voltage is given, so you can directly find the current run by the load. The power consumed by any load. And talking about a single phase load, the power consumed by a single phase load, it is given by P is equal to the VI cos phi. So the power consumed is given, power factor, the operating power factor or the load power factor is given, the voltage, the terminal voltage of the load, the terminal voltage across the load is also given. So you can directly find by applying the formula P is equal to VI cos phi what is the current run by the load, correct or not? So this data has been given to you. I have clearly mentioned what is the data given to you. Now determine the input power and the power factor. Determine the input power and the power factor. Tell me, what is the input voltage? We are exciting the transformer at the rated voltage, that is the 2000 volt. That is 2000 volt. Okay, in order to find the power, what you need to have? We know the we know the expression for real power, that is P is equal to VI cos phi. So V in this case is how much? 2000 volt. What is I? I don't know. Power factor, tell me, what is the power factor? Is it 0.8 lagging? Is it 0.8 lagging? No, it is not 0.8 lagging. 0.8 lagging power factor is the load power factor. But here we have to find the entire power factor of the input power factor, that must be different from the load power factor. If it would be a ideal transformer, then the load power factor must be equal to the input power factor or the source power factor. But this is not the case of an ideal transformer. So obviously the load power factor and the input power factor must be different. Are you getting my point? Don't confuse in this case and directly consider, no, the input power factor would be same, that is 0.8 power factor lagging. No. Now, input power factor and input power. So if input power factor is changing, obviously input power will be changing. So tell me how to approach this question. Data given and what to find. What is the data to be found in this question? You already know. So tell me how to approach this question. By reading this question directly, some idea should come. No, this question based upon this concept. So tell me the concept tell me the concept involved in this question. Here I need to have the concept regarding the equivalent circuit of the transformer. I need to have the concept regarding the equivalent circuit of the transformer. So basically I need to have the input power factor and input power. So I need to have the equivalent circuit of the transformer with respect to this side. This side means the high voltage side, the excitation side. Okay, input power means input कहाँ पे होगा? सोर्स पे होगा. So सोर्स पे एक इक्विवेलेंट सर्किट हमको ड्रा करना पड़ेगा एंड वहीं से हम क्या निकालेंगे? द इनपुट पावर एंड इनपुट पावर फैक्टर. ऑलरेडी यू गॉट द क्वेश्चन, क्लैरिटी मिल गया है. अभी आपको क्वेश्चन सॉल्व करना होगा. आर यू गेटिंग माय पॉइंट? सो 4 ऑप्शंस आर गिवन, सो यू हैव टू टिक एनी वन ऑप्शन. करेक्ट और नॉट? So write down here the solution. So first of all, tell me what is the transformer here. The transformer is 10 kVA 2000 volt and 2000 by 200 volt. So first data is regarding the open circuit test or no load test. So the no load power is 125 watt and the no load power factor is how much? 0.15 lagging. Okay, and the no load test is performed. I don't know, but I am interested about the input that is the source side, and the source voltage is here 2000 volt. That's why actually I need to find the no load current, that is the shunt branch current. That's why, and the shunt branch is with respect to the high voltage side because our excitation voltage is 2000 volt. So I need to find the no load current when it is excited by 2000 volt. Okay, so you know power is given by V into I naught into cos phi naught. So the no load current क्या होगा? W naught divided by V into cos phi naught. So W naught का वैल्यू क्या है? 125 watt divided by V is how much? V is 2000 into power factor is how much? 1.15. So calculate and tell me what is the no load current I naught. I'm directly writing here, already available. It is 5/12. Okay. So the no load current magnitude is 5/12. So what is the angle? Suppose I'm considering voltage as reference. Suppose I'm considering the voltage as reference. So I naught will be lagging behind cos inverse 0.15. Is it correct or not? So tell me what is cos inverse 0.15? It will be 81.37. It will be how much? 81.37. That means, is it a lagging or leading power factor? Yes, it is a lagging power factor. That's why the current lags behind the voltage by how much degree? 81.37 degree. So it would be positive or negative. From reference we know for lagging we take it as negative, and for leading we take it as positive. So it will be minus 81.37 degree ampere. It will be minus of 81.37 degree ampere. Okay. Now let's draw the equivalent circuit. Equivalent circuit of the transformer with respect to primary, which is high voltage side, 2000 volt side. So this is the leakage impedance, because leakage impedance has been given. If it had an ideal transformer, then it would have no leakage impedance. Okay, but this is a case of practical transformer, so obviously we have to consider the leakage impedance also. And this is your shunt branch. This is your shunt branch. ठीक है? First of all, let me draw the transformer model. Then we'll convert entire circuit with respect to primary. First, let's remove this case, not with respect to primary. Okay. Just equivalent circuit of transformer. Okay. So here load will be connected. Here a load is connected. So the load voltage has been given is how much? 200 volt. It is 200 volt, and the load is consuming how much? It is consuming 10 kilowatt at 0.8 power factor lagging. Okay. So again, can you tell me what is the current run by this load? In this case also, we know the power is given by P is equal to VI cos phi. So P is known, V is known, power factor is known to you. So can you tell me what is the current run by this load? Can you tell me what is the current run by this load? Suppose the load current is I2. So I2 का value क्या होगा? It will be P by V cos phi. P by V cos phi. So I'm directly writing the value of load current, which is how much? That is 62.5 minus 36.86. So I2 का value क्या होगा? 62.5, and the angle is minus 36.86 ampere. Why? Because the power factor is 0.8 lagging. So power factor angle will be 36.86. Because this is a case of lagging power factor, So it will be negative. Okay. Now our main target is to find the no load power. So the voltage is suppose 2000 and angle will be suppose theta. Why theta? Why not 0? Because I have considered the load voltage as 200 angle 0. Actually in this question they have mentioned the load voltage as 200 volt but not the phase. So I have to consider the phase as 200 angle 0, and this angle, this power factor angle is with respect to the voltage having the angle of 0 degree as a reference. So it is obvious that the source voltage phase angle will not be 0, it will be different from 0. Why? Because this is not a case of not a case of ideal transformer. This is a case of practical transformer. And what is the voltage ratio? 2000 by 200 volt. Okay. This one is I2. This one is how much? I2 dash. ये क्या है? I0. So I1 dash. This one is I1 dash. Sorry. Neglect it. This one is I1, just I1. Okay. Are you getting my point? This one is considered as I1. Anyway, now what is our target? Our target is to find the input power and input power factor. So input power factor means it is the cosine of angle between the voltage and current. Angle between the voltage and current. So how to find? So what should be the next step here? We have to convert the entire circuit with respect to the primary. Its meaning is the equivalent circuit with respect to the primary or equivalent circuit with respect to 2000 volt. Okay. So again another thing is left. This is the leakage impedance. This one is the leakage impedance. So can you tell me what is the magnitude of this leakage impedance? Tell me, what is the magnitude of this leakage impedance? It is given in the per unit form, but we have to write the absolute quantities. So absolute quantities में लिखने के लिए you might be knowing क्या होता है? We know Z base is given by voltage base square divided by kV base. So voltage base कौन सा लेंगे? वोल्टेज बेस हम जहां पे जिस सर्किट में ये है इसको लेंगे. तो कौन सा साइड में है ये हाई वोल्टेज साइड में है. दैट्स वाई हम क्या लेंगे वोल्टेज बेस को 2000 लेंगे. 2000 एंड केवी बेस क्या है? केवी क्या है? 10 into 10,000. So it will be 400 ohm. It will be 400 ohm. Now the absolute quantity, we know that per unit is equal to absolute divided by base. So absolute वैल्यू क्या हो जाएगा? एब्सोल्यूट का मतलब क्या है? बेस क्या है? 400 इंटू पर यूनिट का वैल्यू क्या है? पर यूनिट. नो, दिस इज नॉट द पर यूनिट, दिस वन इज द परसेंटेज. दिस वन इज द परसेंटेज, मीनिंग इसमें बाय 100 करना पड़ेगा. सो इट विल बी 0.5 प्लस J1 divided by 100 because this one is the percentage impedance, not the per unit. So percentage अगर ये है तो पर यूनिट क्या हो जाएगा? 0.005 plus J 0.01. This one is the per unit. This one is the percentage. That's why I divided by 100. Okay. So absolute value of impedance का absolute value of impedance क्या होगा? It will be 2 plus J4 ohm. It will be 2 plus J4 ohm. So ये एलिमेंट का मैग्नीट्यूड क्या है? 2 plus J4 ohm. Okay. Now let me draw the equivalent circuit of the transformer with respect to the primary side, and the primary side is 2000 volt. So अगर I2 है, the load current is 62.5 ampere. So what will be what is the reflection of this I2 in the high voltage side? In the high voltage side में load current का reflection क्या होगा? You know the relation, that is the MMF is constant. That means N1 I1 is equal to N2 I2. So I2 dash का वैल्यू क्या? I2 dash का वैल्यू क्या होगा? It would be see, हाई वोल्टेज साइड में हमेशा करंट क्या होता है? कम होता है, and it would be 1/10 times, meaning transformation, you know this relation, that is N1 I2 dash is equal to N2 I2. So N2 by N1 is nothing but the voltage ratio 200 by 2000. So क्या होगा? I2 dash would be 1/10 times of the load current. So I2 dash will be 6.25, angle is minus 36.86 ampere. Okay. Now let's draw the equivalent circuit with respect to primary. Okay, here the load current is how much? I2 dash is equal to 6.25, angle is minus 36.86 ampere, and ये क्या है? 200 angle 0. Okay, and this current is how much? You know, and ये है 2 plus J4 ohm. So you know the value of I0. I0 का वैल्यू क्या है? 5/12 minus 81.37. 5 divided by 12 minus 81.37 ampere. Correct or not? So यहाँ पे प्राइमरी साइड करंट क्या होगा? अप्लाई KCL at this node. So I1 will be I0 plus I2 dash. I0 plus I2 dash. So I0 is equal to 5/12 minus 81.37 plus 6.25, angle is minus 36.86. So can you tell me the value of I1 here? Calculate and tell me the value of I1. So it will be 6.5536. Angle is how much? Minus 31.41. Minus 31.41 ampere. Minus 31.41 ampere. Okay. So this is the primary side current. But don't think that the primary power factor will be cos minus 39.41. Okay. क्यों नहीं होगा ये? Because power factor is nothing but the cosine of the angle between voltage and current. अगर वोल्टेज 0 डिग्री होता, वोल्टेज का फेज एंगल 0 होता, तब जाके द इनपुट पावर फैक्टर कोसाइन ऑफ 39.41 होता. लेकिन इन दिस केस वी डोंट नो द इनपुट वोल्टेज का एंगल, द फेज एंगल ऑफ इनपुट वोल्टेज वी डोंट नो. आई हैव कंसिडर्ड दिस एज थीटा. So first of all we have to find this value of theta. How to find this value of theta? Tell me. So we can apply KCL at this node. No, first of all, another wrong thing I have did. This voltage also I don't know. Okay. So apply KCL at this node, so apply KCL in this loop. So I1 you know, I1 you know, and this voltage you know. So applying KCL, in the loop, we get V angle theta is equal to 200 angle 0 plus I1 into 2 plus J4 is equal to 200 plus 6.5536, angle is minus 31.41, 2 plus J4. Okay, so calculate and tell me what is V angle theta. Directly I am writing here the value of V and theta as 2026.8 and angle is 0.3372 volt. Okay, so don't think that input side voltage or the supply voltage would be 2000 volt. No. Why? Because this is a practical transformer, and suppose the load is operating. First of all, tell me what is the rating? What is the rating of the LV side? It is 200 volt. It is 200 volt. So obviously, as this is a case of practical transformer, the supply voltage must be not the rated voltage. The rated voltage is 2000 volt. So it must be higher than 2000. Why? Because there is a voltage regulation in the transformer. Your load, in order to operate the load at the rated voltage, I have to excite the transformer at overrated voltage. I repeat, in order to operate the load at the rated voltage. What is the rated voltage of the load? 200 volt. So I have to apply the primary side voltage much higher than the rated one. Not much higher, just higher than the rated one. So the rated voltage in the primary side is how much? 2000 volt. But I have to excite the primary side voltage at 2026.8 volt. Then only I can operate the load at 200 volt. Are you getting my point? Now come to the target, final target. Our prime target is to find the input power. So can you tell me power का expression क्या होता है? हमेशा it is given by VI cos phi. So V का वैल्यू क्या है? 2026.8 इंटू I का वैल्यू, I मतलब यहाँ पे I1 होगा, I मतलब I1. So I1 का वैल्यू क्या है? 6.5536 इंटू cos phi. phi मतलब क्या होगा? phi का मतलब क्या होगा? Phi is nothing but the angle between the voltage and current. Which voltage, which current? That is the input voltage, input current. So phi यहाँ पे क्या होगा? It will be minus 36.86 plus 0.3372. Okay, meaning 36.86 plus 0.3372. Suppose this is the 0 degree, voltage यहाँ पे है, करंट यहाँ पे है. So ये दोनों का एंगल क्या होगा? That is the पावर फैक्टर एंगल. So इसको हम क्या करेंगे? दोनों को मिला देंगे. तो क्या आ जाएगा? 39.7512. It is 39.7512. So the final answer for this question will be approximately 10.2 kilowatt. It will be 10.2 kilowatt, and input power factor will be how much? Input power factor will be how much? It will be cosine of 39.7512. Cos 39.7512. So इसका आंसर क्या आ जाएगा? 0.7688 लैगिंग. 0.7688 lagging, and this is a MCQ type of question. So can you tell me what would be the correct answer out of 4 options? So I think option C is correct one. 10.2 kilowatt, 0.768 lagging. So hence the correct option will be, hence the correct option would be C. Okay, so this is all about question number 3, and this question is based upon the equivalent circuit concept, and of course this is a little bit lengthy question, but through this question many concepts would be clear regarding the equivalent circuit of the transformer. So hope all of you understood this question, and thank you all of you for watching this video. We'll meet with another interesting question in the next episode. So wish you all the best. God bless you.